Hello and welcome to the sample exam questions, space physics. Okay, I supposed to have a little animation there. There we go, it's playing. Equations. So let's go to learning objectives. I'm quite straightforward today because I'm just talking about how to do questions. So understand what the question is asking and number of marks. I'm very focused on exam technique in this session. And learn how to plan to answer a longer question. So think about what it's asking you again. And how to keep exam answers succinct to gain maximum marks. So the order succinct to gain maximum marks. I'm going to ramble on because it's kind of wasting time. So let's have a look. Being succinct, we're going to be succinct about this. So number one. So these are all from exam papers that I've taken from real exam papers. So satellites are used to gather data about the origin of the universe. So satellites are above our above our atmosphere, not on the ground. The Big Bang Theory is a theory about the origin of the universe. This is going to come up a lot. Okay, it's going to be a sort of a similar theme throughout all these questions, but they're going to be asked in very different ways. So that's the point of this video. Evidence for the Big Bang Theory is provided by redshift and CMB radiation. So you have to remember cosmic microwave background. Sometimes called the CMBR, because they don't put the radiation. The R stands for radiation, cosmic microwave background radiation. Describe what is meant by redshift. Okay, so have a think for a minute about what redshift is. Okay, so there was a video, another video, called The Expanding Universe that I've made, which where I describe redshift. So you might want to look at that or look at a book or the other rest of the internet before I tell about how to answer this. Also note the number of points too. So you're going to have to say two things here. That always gives you a clue. If it's one, you say one thing, two things, and so on. Okay. So let's have a look at the answer. This is also my mark scheme I'm showing you. So redshift, so wavelength of electromagnetic radiation increased. Okay, so the wavelength of redshift is the wavelength increasing. So these mark schemes you have to sort of, they're not written as how you'd write the answer always. So obviously there's someone looking at marking it. So you need to write a full sentence in yours. Okay, so again, we'll go over writing a full sentence, but just for them now looking at what it's looking for, because these sort of 2-point questions looking for succinct answers. So redshift is an increase of electromagnetic radiation's wavelength. You could also say frequency decrease, but I'd stick with wavelength just not to confuse yourselves. Okay, so on the additional guidance desk for raw mark scheme, people marking it. Okay, if someone mentions an object, you said a star, but it doesn't matter. Towards red ends of the spectrum, also allowed. Okay. As the star, and when they put brackets there, then mean that you could have said planet or galaxy there. Okay, I think it would have been any object would have been okay. Moves away from us. So redshift is the increased wavelength of EM radiation as the object. Okay, so star, planet, galaxy moves away from us. Okay, so there's 2 points we made there. So explain how redshift provides, this is part of the same question, same paper, so it's got 2 at the top there. So it's following on. Explain how redshift provides evidence for the Big Bang Theory. So obviously the redshift we just described provides evidence for the Big Bang Theory. Okay, so we know that if the galaxies are moving away from each other, they are redshifted, that means the universe is expanding. Okay, so it means the universe is expanding from all the way from each other, and it means it started from a certain point. So you say the redshift indicates that all the galaxies are moving away from us and each other. That's why that's in brackets, and each other. Okay, and another thing to point out is, this would be in other questions as well, the further away the galaxy is, the faster it's moving away from us, which indicates the universe is expanding. And if it's expanding, that means it had an origin, it had a beginning. Okay, so if it means obviously it started at a smaller point in the past, and is expanding into a larger size now. Okay, have a think about how we'd write that in full sentences. Okay, the cosmic microwave, or cosmic background explorer, sorry, that's the name of the probe there. So the cosmic background explorer, COBE, as it's known as, satellite observed cosmic microwave background radiation. Yes, it's kind of a tongue-twisting sentence, that one. So COBE is a satellite, and CMB radiation, cosmic microwave background radiation, is radiation we know about. And the COBE satellite, that's why they shortened it. It's quite a mouthful to say that. Explores the cosmic microwave background radiation. Yes, it's a satellite, so it's above the atmosphere. So we know that because I've kept saying it. State what the M in CMB radiation stands for. Microwave, cosmic microwave background radiation. It's in the microwave region of the spectrum. It doesn't mean it cooks food for you if you stick it in the sky. It's in the microwave region of the spectrum. The microwave in the kitchen, which I can see my microwave because I'm in the kitchen table. It's actually, its full name is microwave oven. Okay, so it uses microwave. So it does use the same wavelength as the microwave background radiation. Okay, and then we're asked what is meant by cosmic microwave background radiation or cosmic background radiation. Yeah, they do kind of interchangeably. The full name is the one I keep saying, cosmic microwave background radiation. They shorten it, but it's the same thing. I say the exact thing quite a lot, obviously, because I teach students. Microwave, yeah, as I've just said, is the answer. And the answer to what is it? Radiation, okay, that comes from all over the sky. So wherever you point your sort of microwave detector, that it would appear to come from everywhere, and it's leftover radiation from the Big Bang explosion. Okay, it was a really big piece of evidence. That's why it's obviously, they ask it a lot in these exams for the Big Bang and not the steady state. There must have been something to cause it. Okay, explain how the presence of CMB radiation provides evidence for the Big Bang theory. So we're just kind of putting the two things together that we've been talking about. So it means the Big Bang theory has a beginning or initial explosion. So an explosion from a point that releases or gives out radiation. So the radiation is still there. Okay, all over the sky, it's still there. Okay, so other things in say similar vein, but these are asked in a different way. Okay, these are asked in a different way. So in 1929, the astronomer Edwin Hubble observed that light from galaxies moving away from the Earth had longer wavelengths than expected. Okay, so what name is given to this effect? So give you just a moment, just to show you. So what name is given to this effect? So it is the redshift. So it was from Hubble's observations, okay, that we've got the redshift there. Okay, redshift. So I'd like to have a look at this graph quickly. So from his observations, Hubble was able to calculate the speed of a galaxy and the distance of the galaxy from the Earth. So figure 1 shows results of Hubble's calculations. So what relationship between the speed of a galaxy and the distance is suggested by Hubble's results? So I want people to have a look there. Just pause the video and have a look. Okay, so what is it? So you've got a linear relationship. So relationship, okay, is that the further the galaxy is away, okay, the faster the galaxy is moving away from us. Okay, so if you look here, distance in kilometers and the speed of the galaxy from the Earth. Okay, so I've written out for you, the further away the galaxy, the faster the speed of the galaxy. So that's a linear relationship there. Okay. So let's have a look at this one. In the 1950s, there were two main theories. Just be careful here because they could give you theories we may not have heard of before. They can do that if they give you the information. Okay. So in the 1950s, there were two main theories how to explain how the universe began. So the universe has always existed, this is theory 1, and is continually expanding. New galaxies are formed as older galaxies die out. Theory 2. The universe began from a very small region that was extremely hot and dense. The universe has been expanding ever since. So the question is, there's only 1 mark. In what way do the observations made by Hubble support both theory 1 and 2? So let's look at Hubble's data again. The one we need to carefully look at. Okay, you need to spend a bit of time looking at that. Okay, so Edwin Hubble, okay, looks at the same person which the Hubble Space Telescope is named after. Okay, they did this in the 1920s. So distance in kilometers, speed of galaxy again. So the further the galaxy is away from us, the faster it's moving. That means that the universe is expanding. So theory 1 and theory 2 both support the idea that the universe expands. Okay, so Hubble's observations of redshift support an expanding universe. Okay, most scientists now believe theory 2 is correct. You probably know that as a Big Bang theory. Suggests what is likely to have caused scientists to think theory 1 is wrong. So be careful with that question, because you probably think it's asking what's the evidence for Big Bang, but it's not. It's saying what is likely to have caused scientists to think theory 1, you go back to it, why that is wrong. Have a think. Okay, now go through it. So there is no evidence of galaxies being created or destroyed at this moment in time. So in that theory 1 needed galaxies to be created and destroyed, but there's no evidence of that at the moment. That's not in the cosmic microwave background or redshift, nothing to do with those 2 things. Okay, so this is one that can catch people out. That's why I put it in, because as well as redshift, you can be asked about blueshift. So as we know, redshift is objects moving away, but blueshift can be local objects that are moving towards us. Okay, so again, have a close look at this diagram before answering. Okay, so have a look. So all A is the same as the sun. So this is a spectrum. A is the same as the sun. B is blue shifted. C is red shifted relative to the sun. And D is blue shifted. But there's sort of a slight thing in the question where it says speed of B compared with the speed of star D. So B and D are both blue shifted towards the blue end of the spectrum compared to the sun. But D is blue shifted more. So D is moving towards us or towards the sun faster than star B. That's a question, because it's blue shift that can easily catch people out. So there's one about Big Bang again. It's asked a lot in these exams. So the Big Bang theory is one theory explaining the origin of the universe. The graphs X, Y, and Z show the size of the universe may have changed with time. Okay, so we've got this one, which is going straight along. One in the middle, it's got an origin expanding. This is the size. And this one, but it doesn't start at the origin. So which graph would the Big Bang theory suggest is correct? Write your answer X, Y, or Z in the box and then explain it. So again, have a think. Okay, we'll go through it. So Y, the second graph, is the most likely to be the Big Bang theory, as the universe started from a tiny point and has been expanding ever since. Okay, so it's starting at an origin point. That's a very important thing, the Big Bang theory, to start at an origin point. This one's the same size, so that's not the Big Bang. This one's not starting at a single point, it's starting at a certain size. Okay. Now, again, we've got one which can easily catch people out about stars. These are stars, not galaxies. Okay, so you've got star A and star B and a central point. Okay, that's not a physical object, that's just a point we've chosen. So many stars are part of a binary star system, so there's 2 stars. Binary star systems have 2 stars. The visible spectrum from stars includes dark lines, even spectral lines, remember? These lines are at specific wavelengths. The diagram shows the position of 2 dark lines in the spectrum from the sun. So that's a reference point. It also shows the same line, so it could be the same element, it could be something like sodium, okay, in the spectrum from stars A and B in a binary star system at the same point in time. So that's increasing wavelength, that's red end, that's the blue end. The sun. Star A, redshifted, star B, blueshifted. So what name is given to the effect shown in the spectrum from star A? Just said it accidentally. So star A is redshifted. Redshift. Yeah, again, so it's same answer for a different question. Okay, so same question following, so same diagram we can refer back to. Scientists have concluded that there's 2 stars in a binary system orbit about a fixed point between 2 stars. Let's look at the diagram again. There's the diagram. Okay, so you can pause that or put that into a different document to look at while you think this question. A comparison of the spectra from the 2 stars in a binary star system provides evidence to support this conclusion. Explain how. Okay, so that's using the data here. So how do they know that they're orbiting like that? That's basically what they're saying. Okay, so I would say 1 star spectrum is blue shifted. Okay, so that would be star B, I should say star B there, is blue shifted, implying that the star is moving towards us. And the other star is red shifted, indicating the star is moving away from us. Putting these together, we can conclude that the stars are orbiting around the central point. Okay, so you could draw a diagram with this as well and draw it, obviously one's going away and one's going towards, like the diagram. Okay, so the Big Bang Theory uses redshift as evidence. So this is part of the question with the stars, so it can go into galaxies again. If you get a question about stars, it can still talk about galaxies on another part of the question. The Big Bang Theory uses redshift as evidence to explain the beginning of the universe. How does the redshift from distant galaxies provide evidence for the beginning of the universe? Now have a think again. Okay, now we'll talk about it. So redshift occurs as the wavelength of light is stretched out and moves towards the redder end of the spectrum. The further the galaxy is away, the greater the light is redshifted. This indicates the universe is expanding. If the universe is expanding, it must have expanded from a smaller size in the past, indicating an origin or beginning. So you can see there's a big central theme running through this, but it can be asked in different ways, I suppose, questions. Some of them share the same explanation with different things. Okay, so have a look through that. Obviously, the video, it's recorded. You can pause and go back and work through as fast or slow as you like. So hope you've enjoyed this video. Thank you, and I hope to see you in one in the future. Thank you. Goodbye.